Hello and welcome again to another episode of Algebra Workout. I'm Sally Ann Keyser and this is Alan Borthwick.
We're going to be looking at square roots, which are sometimes a bit tricky to deal with. We'll be showing you some techniques to try to ensure that you don't make silly mistakes.
Once again, I'll be looking at some examples and then Alan is going to go through some general rules to help you. So let's get ready. I'll start by introducing you to one of those tricky issues. Look at this equation. X is equal to the square root of x plus 2. I'll have a go at solving it. Suppose I start by squaring both sides. That gives me x squared is equal to x plus 2. And bringing this all over to the left-hand side, I have the quadratic x squared minus x minus the 2 is equal to 0. Now I need to factorise that. And I can see that it's x minus 2 times x plus 1, all equal to 0. So I have my solutions. X is equal to 2, or x is equal to minus 1. But what happens if I substitute this back into the original equation? Well, when x is equal to 2, that gives me 2 is equal to the square root of 2 plus 2, which is 4, which is 2. So that's correct. But when I substitute x equals minus 1 back into the equation, that gives me minus 1 is equal to the square root of minus 1 plus 2, which is the square root of plus 1, which is 1. Minus 1 is equal to plus 1. So there's something funny going on there. The solution x equals minus 1 doesn't work. You have to be careful when there are square roots around, and I'm going to hand over to Alan to explain some basics.
Thanks, Sally Ann. OK, there's a convention we use which says that where a is any positive number or 0, then if the square root of a is b, that means that b squared is a. Now, when we write the square root of a, we always mean by convention the positive root. So b is also positive. Let's look at some examples using real numbers to try and clarify that. Suppose a is 1. Well, in that case, the square root of a is b, 1, so that 1 squared would equal 1. Let's try another couple of examples. Say we have the square root of 4 equals 2. Well, that simply means that 2 squared equals 4. Another one, the square root of 81 is 9. So that means that 9 squared equals 81. Now, one thing you might have noticed here is that the square root of a number is smaller than the actual number. But careful, is that always the case?
Well, what about the square roots of positive numbers less than 1, though? The square root of a quarter is a half, because a half squared is a quarter, which is different from these examples Alan's used.
OK, well, let's have a look in some more detail at square roots of fractions and decimals. What about if you consider 2/10 all squared? Well, in that case, you get 2 squared over 10 squared, which is 4 over 100. Or in decimal terms, 0.2 squared equals 0.04. So in this case, when you're looking at numbers less than 1, squaring gives a smaller number. Now, making the link to the left-hand side of the screen, the square root of 0.04 equals 0.2. Right, let's do the same sort of thing for 81 and 9. Now, 9/10 all squared is 81 over 100, or in decimal terms, 0.9 all squared is 0.81. And you can now say that the square root of 0.81 is 0.9, which is again larger than 0.81.
OK. Remember, when you use the square root sign, then the answer is always positive or 0. It's never negative. So, going back to my original problem, only x equals 2 is a solution because only 2 is positive. So where did this incorrect x equals minus 1 come from? Well, suppose the original equation had been this. Minus x equals the square root of x plus 2. If you solve this equation by squaring both sides, then you get the same quadratic equation as before, with the same solutions 2 and minus 1. Now, x equals minus 1 is a solution of this new equation, but x equals 2 isn't. Try it and see.
So remember that the solutions of a squared equation may not be the solutions of the original equation.
Now I'm going to look at another problem. Look at this equation. It's the sort of equation you might come across when studying conics. 9x squared minus 16y squared is equal to 144. The task is to make y the subject of the equation and solve for y. So I have minus 16y squared is equal to 144, bringing the 9x squared over to the other side becomes minus 9x squared. And multiplying through by minus 1, that gives me 16y squared is equal to 9x squared, that now becomes a plus, minus 144. And dividing through by 16, that gives me y squared is equal to 9x squared minus 144 all over 16. But it's not immediately obvious what to do next and how to get the expression down to a simple form to solve for y. So I'm going to let Alan intervene here with some more rules for how to handle square roots.
Thanks, Sally-Anne. Right, quiz time. Coming up is half a dozen identities, not all of which are correct, so be warned, don't believe everything you see. Now, as before, A and B are always positive. And I'm looking for a list of correct relationships for how you might manipulate sums and products of square roots. Oh, and by the way, you'll see in a moment the significance of this rubbish bin. Right, first of all, the square root of A plus B is equal to the square root of A plus the square root of B. Or is it?
Doesn't look quite right to me.
OK, well, let's have a look. Do a test. That's always a good principle, by the way, in maths. Do a test. If A is 9, and b is 4, then we get square root of 9 plus 4 equals square root of 9 plus square root of 4. Root 13 equals 3 plus 2. No way, into the rubbish bin. Second one, the square root of a times b, is that equal to the square root of a times the square root of b?
I'm more comfortable with that formula.
OK, let's test. Letting a equal 9 and b 4, what happens? Let's watch. So we end up with the square root of 36, which is 6, equaling 3 times 2. That particular case is true. It doesn't always mean, by the way, that a general case will be true, but it is in this case. So the general case is the first rule we're going to use here on our list. Right, let's have the next one. The square root of a minus b, is that equal to the square root of a minus the square root of b?
That's very similar to the first one, which was wrong. Let's check it.
OK. Well, using 9 and 4 again, on the left we have the square root of 5. And is that equal to 3 minus 2? I don't think so. Into the rubbish bin. Right. 4. The square root of a over b, is that equal to the square root of a over the square root of b? Let a equal, as we said before, the number 9 and b 4. Let's see what happens. So we're getting on both sides 3 over 2 equals 3 over 2. Correct in the particular case, so the general case becomes our second rule. There's another couple I'd like to mention, by the way, before we finish. The first is that the square root of a squared is always equal to a. And secondly, the square root of a all squared is equal to a. So we have these 1, 2, 3, 4 very important identities to do with square roots.
Right, well, with all of that on board, I can now go back to my last example and manipulate it in the right way to make y the subject of the equation. Now, I said before that y squared is equal to 9x squared minus 144 all over 16. Now, if I take the square root of both sides, that gives me y is equal to plus or minus the square root of 9x squared minus 144 all over 16. Now, using Alan's second rule, that gives me y is equal to plus or minus the square root of 9x squared minus 144 all over the square root of 16. Now, it might be tempting here just to square root the 9x squared and square root the 144. But if you remember, that was one of the rules that Alan threw into the rubbish bin. But what I can do here is bring out the factor 9. So that gives me y is equal to plus or minus the square root, bringing out the factor 9, of 9 times, in brackets, x squared minus 16, because 16 times 9 equals that 144, all over, not forgetting the square root of 16, which is 4. So that gives me, using Alan's first rule, y equals plus or minus the square root of 9 times the square root of x squared minus 16, all over 4. Nearly there. So y equals plus or minus the square root of 9 is 3, so that's 3/4 times x squared minus 16. So y equals plus or minus 3/4 times the square root of x squared minus 16.
Well, that might have looked difficult, but if you remember the rules for manipulating square roots and make sure you're careful, you should be fine. Good luck and goodbye.
Goodbye.